Okay, so this is what's happened is I went back because I couldn't find my handout on the gas laws for 13, 18, 21, 22, 23, and 24. And I scrolled back in the Google Classroom and opened up that gas laws worksheet that I gave you earlier. And I realized that that's the old worksheet. And that could be the reason why people are having a hard time with this, is you're looking at a worksheet that is outdated. And the new worksheet is got less problems, like I mentioned before. And so it's going to be a lot more obtainable to finish off these problems. So this is the deal. I went back to the old Google Classroom post and I removed the incorrect gas worksheet and replaced it with the correct gas worksheet. And if you just pause the video at this point, you can see all the problems that I want you to do: 13, 18, 21, 22, 23, and 24. Now, we did 13 together. I thought today it would be probably a good idea to do 18 together, because I feel like I'm losing a lot of you on these problems, and I don't want that to happen. I want us to be successful. So let's go ahead and work through 18 as a group, and I'm going to be reading it off of this screen and solving it on another piece of paper. So I'm going to set this down and get my paper organized, and we are going to figure out how to get, oh, look, there's the background. We're going to figure out how to get this problem done together. So let's, I hope you can get access to the problem and read it along with me. It says that we have an air thermometer, and it's going to be constructed by attaching a glass bubble. You guys all know what a thermometer looks like. So we've got this bubble and maybe some readings on it, and it's attached to a small little piece of tubing. The tubing is going to contain colored water that rises when the temperature increases and the trapped air expands. So we've got some colored water in here. It's usually red, isn't it? And it's going to expand, and we're going to have this movement of the colored water as the temperature increases or decreases. Now, remember, it can be helpful to draw a picture. Even if the picture means nothing in helping you solve the problem, it can just help ground you to the problem and put you sort of in a mindset where the problem, you start saying, okay, I can solve this problem one way or the other. Because you can. You just need to have confidence and start writing stuff down. And the stuff that you write down eventually will start fitting together into an answer. And this is true with a lot of things in life. Little baby steps. Start with what you can do, and that might cascade into more things that you find you can do until, you got the problem solved. So let's go back. The tubing contains and raises and trapped air expands. Okay, you want a 0.20 centimeter cubed change in volume to equal a 1 degree Celsius change in temperature. So that's temperature and that's volume. And what total volume of the air? Okay, so what total volume of the air? That's our question mark. At 20 degrees. At 20 degrees Celsius should be trapped in the apparatus below the liquid. Okay, so this is a problem that's dealing with volume and temperature. Clearly, we've got Only two things that we're looking at. So this is not the combined gas law. If we're looking at volume and temperature, we would have to go back to the one that deals with volume and temperature, and that is, what is it, Charles's law? No, that's the Gay-Lussac's law. So, no, pressure and temperature is Gay-Lussac. So yeah, I was right. It is Charles's law. Okay, so let's go ahead and write in volume 1 over temperature 1 is equal to volume 2 over temperature 2. Now, how did I do that? Well, once again, I just looked and saw what variables am I working with. And then I went back to my sheet that tells me the different variables that are available. And I chose the one that fits that, and it's this one. And so now all I need to do is plug my numbers in and solve. So I'm going to take, and I'm going to be solving for volume 2. So I'll rearrange this equation to leave volume 2 alone. So what I get is, if I move this up here, is I'll get T2 times V1 divided by T1 is equal to V2. Okay, and since V2 is what I'm solving for, I can go ahead and plug in. Temperature 2 was 20 degrees Celsius. And I want to add 273 to that because of the Kelvin thing. And I want to find my volume 1, which is 0.20 centimeters cubed, and divide that by my volume, or my temperature 1, which is 1 degree Celsius plus 273. So there we go. There we go. Now all we have to do is run these numbers on the calculator. So get your calculator handy. And I've got 20, 273, and 0.20. And I'm going to save that and add 273 with add 1 to it and divide. So I get 2.14, or no, sorry, times 10 to the negative 1. So it's going to end up being 0.214 centimeters cubed. All right, piece of cake. So that's 18 and 19. Let's go ahead and scroll ourselves on down. I want you to try, just try it. No, I'm sorry, 19 isn't a problem. 21 has to do with a weather balloon, and it is going to be a volume, temperature, and pressure problem. So maybe help you get it set up. So go to 21, and we have a weather balloon. And so I'm going to draw it because I like to do that. And my weather balloon is at 2.94 kiloliters of helium at a location where the pressure is, so at this point we're at 1.06 atm. So that's my volume. Remember, check your chart to see what we're talking about. And this is pressure. And we also have a temperature of 32 degrees Celsius. What will the volume of the balloon be when the altitude changes and the pressure is different? So the same balloon is going to go through a pressure change. And so we're looking to see how that will change the volume. So question mark on the volume. And we do know that the pressure in the new set of situations is 0.092 atm, and the temperature is 35 degrees Celsius. So there you go. This is a combined gas problem. So you'll need the combined gas law. We've got pressure 1 times volume 1 divided by temperature 1 is equal to pressure 2 times volume 2 divided by temperature 2. Now, I want you to just do it. Get that baby solved based on all that information I've just given you. I know you can do it. Just plug and chug. All right. So that'll be your goal. I want to see 21 for sure done. And you only have 3 more to go. So let's see if we can't get those sort of ironed out so we can move on because we have other stuff to learn. Okay, bye.